Hey, 30-1s. Here is the second part of graphing sine and cosine. What we're going to do now is we're going to build on the last lesson, and we're going to add in some stretches to it, the vertical and the horizontals. And we'll see how do these affect our graph and how do we draw that. Recall from the last video, what we were looking at was the basic graphs of sine and cosine. So here I've drawn sine theta, and again, where that graph comes from are the y coordinates of our unit circle. What we're about to do here is we're going to start vertically stretching it and horizontally stretching it. So what we are going to look at is this, transforming our graph to become that. So in this lesson, how do A and B affect our graph? Well, A is really easy. A from our prior transformations unit, we know is the vertical stretch. This is our vertical stretch. So if I had changed this function to say this was a 2, well, what's going to end up happening is that's our vertical stretch. It's going to multiply all of our y values. Well, our invariant points then would be on the theta axis, and we're going to multiply all our y values by 2. So at 90 degrees, we have a max of 1. So we now have a new max way up here at 2. Our new min would be way down here at -2. And every other point in between would also get multiplied, the y value by 2. And that would be our new graph. And remember, this thing keeps going in both directions. A lot of the times on a question, it's going to ask you to draw 2 periods so that we can see the pattern repeating, and you would be a little bit more specific drawing your points. Now, that's our vertical stretch. That's easy peasy. In sinusoidal functions, in trigonometry, even though it's a vertical stretch, we like to refer to this value as the amplitude. So the amplitude, look at the purple graph here, the amplitude is how much the graph goes up and down from the middle. So I'm going to draw the middle of my graph in. The middle of both graphs is right here. Happens to be the theta axis. So the amplitude is how much we go up and down from the middle, also known as the midline or the median line. So on the purple graph here, this distance right here, that's the amplitude. That's an amplitude of 2. If I went down, the amplitude is still 2. Amplitude is always positive. If there's a negative, we're going to think of that as a reflection. So just like in transformations, we keep our stretches and reflections sort of separated. We describe them separately. That's it. That's amplitude. If I was looking at the original graph we had, well, look at the A value is 1. So the original amplitude is simply just 1. It's right there, or it's right there. So if I give you the graph, you can tell me the amplitude. And if I give you the function, well, now you know the effect that has on the graph. And it's the exact same for cosine. So that's pretty easy. What's going to be more complicated is this parameter of b, and how does that affect our graph? Now, let's look at this b value. We know from transformations that this is a horizontal stretch by a half. Again, don't use abbreviations on a test. Bad teacher. But it's a horizontal stretch by a half, which means in transformations, we would multiply all of our x values by a half. It's really the same thing here. However, what I'm going to say this time, instead of an x, that's a theta. Okay, so we're going to multiply all of our theta values by a half. So essentially, what I'm going to do is I'm just going to go through, well, 0, 0, that's not going to change. 180, well, that's going to come over here to 90 then. 180 times a half is 90. 360 times a half is 180. And here's how I want to start drawing these graphs a little bit easier. I know this point up here is originally it's at 90 degrees. So 90 times a half is 45. The other way I want to think of this is a maximum. It's halfway between these x-intercepts. Well, what's halfway between 0 and 90? 45. So there's two ways to look at finding where these points are going to end up. What I really want you looking for is thinking of patterns. Okay, where are the points going to end up with a pattern? So here's 45 degrees. And so it's going to end up here. Okay, I keep going. Halfway between 90 and 180. Well, that's this minimum over here. So halfway between 90 and 180 is 135. That's the same as saying 270 degrees multiplied by a half. Look at what this new shape of our graph looks like. When we start to draw this graph out, what it does is it compressed our graph. Look at that. Look at how much closer together all our points are. Well, that makes sense. We horizontally stretched by a half. So we changed all our theta values, but what else did we change? We also changed the period. What's the period of that blue graph? Well, the period of the red graph is originally 360 degrees. Look at the period of the new graph. How long does it take to repeat? Well, it starts at 0, 0 at the origin, and it repeats over here at 180. The period of this graph is now 180 degrees. Okay, that's important. We're going to make a little rule that's going to help us out. How the b value affects the period. I'm sure you can already kind of see it. All right, well, friends, like I said in the first example, a lot of times we're going to want to draw more than one cycle or one period. Well, I'm going to start using patterns. Look at the distance between all of my theta intercepts. It's 90 degrees. So I'm going to have another theta intercept here at 90 degrees. I'm going to have another theta intercept here at 90 degrees. Halfway between those intercepts, so at right here and at right here, guess what? We're going to have a max and a min because this is periodic. So there's a max right there. And down here, there's going to be my next min. And guess what? There it is. And that graph keeps going. So what I really want you looking for here when you're drawing these is to start to analyze and look for patterns. It's going to help you draw. Halfway between two intercepts is going to be a max. Halfway between the next two intercepts is going to be a min. And I use that pattern to help me draw my graph. Okay, what have we figured out then? We figured out that A is our vertical stretch. But when we're looking at trig functions, we call this our amplitude. The amplitude is how far up and down the graph varies from the midline or the median line. Okay, so right in the middle of our graph. Now, the D value is that median line, which we're going to investigate in the next lesson. But that right there, that's your midline. Okay, so the A value is how much we go up and down from there. That's it. Okay, I like to just count that on my fingers. However, there is a formula that some teachers love, and it's this. You take your max value from your graph and your min value from your graph and divide by 2. But something that's really important, amplitude is always positive. So I'm going to put absolute value bars there because it's my vertical stretch. Done. That's easy. I think most people get that the first time I talk about it. This, however, is a little bit trickier. So the B value we know is our horizontal stretch. The B value is our horizontal stretch. So B is our horizontal stretch. But what did that do to our graph? it definitely stretched all the values, and it took all of our theta values and multiplied them by the reciprocal, right? So it's our horizontal stretch by 1 over b. So we can't forget about that idea of the reciprocal from transformations, can we? Now, the other very important part of this, though, is what did that do to our period, right? How was our period affected? Well, originally, our period is 360 degrees, or 2 pi if we were in radians. But we just horizontally stretch by 1 over b. So when I horizontally stretch by 1 over b, the reciprocal of b, guess what? We end up with a handy little formula. Our period is 360 degrees divided by b, or our period is 2 pi radians divided by b. This is not on your formula sheet. It is in 30-2, it's not in 30-1. This is a very handy thing. It's going to quickly help us answer what's our period, and then when we go to graph, it's going to help us make a scale. Okay, there are the two most important parts of the A value and the B value. Let's look at a quick example here. Let's look at the graph of 3 sine 2x. Let's answer domain, range, period, and amplitude for this function. Well, domain's the gimme, right? Domain's the gimme. It's going to go in both directions forever. Now, my range, well, here's what I know. I'm going to think about maybe what's the amplitude first. The amplitude is 3. So what does that do to my range? Well, our original range is -1 to 1. Well, the amplitude is going to vertically stretch this graph. It's going to affect all the y values. So my new range, if I multiply by 3, is now -3 to 3. Excellent. Very common question for a test. Period. Well, what I see a lot for a wrong answer here is this. I'll even put it in the international sign for wrong, which is the red, isn't it? I'll see a lot of students say this. They'll say, okay, the period is 2. It's the b value. No. The b value is 2. How does that help us? Well, that tells me that we're horizontally stretching by 1/2. So how does that affect our period? Well, if we were doing this thing, let's do this one in radians. I didn't specify, but if our period was 2 pi, I would multiply by 1/2. Guess what? Our period is pi radians. If you wanted to use that little formula that I gave you, you would say this. Period is 2 pi over b. Period is 2 pi over 2. Period is pi radians. And do you see how we end up with the exact same answer? So 2 little quick ways to do that. Now the last question I want to do with you is, I want you to be able to draw this by hand. I know you have a graphing calculator, but I need you to be able to draw these by hand, especially for calculus next semester. So here's what I'm going to do first. I'm always going to go back and think about my base function. And the first little while you're learning how to do this, I suggest you actually draw this out. So I know this. Sine has a maximum of 1, has a minimum of -1. All I need to memorize are my theta intercepts. Because I know this. Sine starts at 0, 0. It has a period of 2 pi, and my theta intercepts are at 0 pi, 2 pi. Remember, this all comes off your unit circle. But watch how I'm going to draw this. Halfway between my first 2 theta intercepts is my max. Halfway between my next 2 theta intercepts has to be my min. And I'm going to draw it with a nice smooth curve. And it keeps going, of course, in both directions. All right, there's the original. Now what I'm going to do is I'm going to look at our new transformed graph, or what I'm being asked to draw. A couple of things I want to recognize. Okay, my amplitude's 3. I've been vertically stretched by 3. So my max is now going to be 3. My min is going to be down here at -3. Perfect. Like we said before, this thing's been horizontally stretched by a half. Now, here's what I'm going to do. I'm going to use the pattern from my previous graph. I'm going to horizontally stretch all of my theta intercepts. Well, 0, 0 is invariant. That's not going to change. But pi will move to pi half. It's divided by 2, right? Or multiplied by a half, however you want to think of it. 2 pi is going to go to pi. Then, halfway between my two intercepts, my first two is a max. Well, that's at pi quarter. Halfway between my next two theta intercepts will be a min. Well, that's going to be down here. And I just realized I drew that other one in the wrong spot, didn't I? It's going to be up here. Okay. And now I've got pretty much everything I need to draw this graph. I've moved kind of my key points. I've moved my theta intercepts. I've moved my max. I've moved my min. And there it is, just like that. And this part right here would be 3 pi half, halfway between pi half and pi. Oh, sorry, 3 pi quarter. I'm a liar. 3 pi quarter. There it is. Okay, a really easy way to sketch this. Now, if I wanted to draw 2 periods or 2 cycles, all I'm going to do is repeat the pattern. Is I see all these distances on my theta intercepts are all going up by a quarter. So I would just keep going. So I would just keep labeling 5 pi quarter. Well, 6 pi quarter is 3 pi over 2. 7 pi quarter. 8 pi quarter. Well, that's 2 pi, right? And now all I got to do is just keep repeating. I like to do my theta intercepts first. The distance between all of those is that, right? And now all I'm going to do, max halfway between there, min halfway between there, and there it is. Boom. Okay, so friends, it can be long and involved. Picture what we're going to do in the next video. We're going to start translating this horizontally and vertically. So it's going to get a little bit more complicated. So make sure you've mastered this before you move on to that lesson. There it is, friends. Good luck. See you next time.